This conversation today we're talking about is Docker. I want to welcome you all here. I've been working with even though I work with can everybody hear me? If somebody could just type a yes on the comment line, that'd be great. Yes, thank you. Okay, so I work in the cloud product strategy team, but a few months ago, Matt Hicks and a few others decided that they wanted to have a big drive towards both Summit, which just recently finished, and the RHEL 7 release, which is any day now, I think, it may be tomorrow. And so they asked for some people to join teams to see if we could try to get stuff out fast. So I was asked if I would join what they were calling at the time the App Infra team. And the first thing they asked me to do was to work on the Docker man pages. So I jumped on the chance because when you're doing the Docker man pages, you kind of have to learn a lot of Docker. So that's my main contribution. If any of you have Docker installed on your machine, you can run, if you run any man Docker, say run or man Docker space pull, you'll see the man pages there. My name is on the end. Yay, me. Anyway, I got a nice t-shirt for it. So that's great. For those of you who don't know what Docker is, sorry, by the way, that's my sort of bio there in the background. If you do go up to GitHub, I'm IP Babel up there, and that's where I kind of pushed some of my contributions up to and did my pull requests from there. Before Red Hat, lots of distributed computing and integration and SOA stuff. And I've been with Red Hat for about 6 years doing a lot of emerging technology stuff. So I did a lot of MRG, and some of you will remember me from the old days there, way back as far as KL's, the Tech Summit up in Kuala Lumpur. And of course, now I've been recently working here. So what we're just going to do today, we may not get to the last one, but we'll do an introduction to containers and Docker and then do some hands-on with Docker so you can see what all the fuss is about and why it's so cool. Red Hat's been investing in Linux containers technology for a while. I'm not going to spend a lot of time on this because it's more of an external slide. But if you look there under obviously in February 2005, when we launched SE Linux, that becomes a big part of what we're doing today with containers and Docker. Also, the C group started with Google in 2006. If we move down to May 2011, we see that OpenShift Online launched, and with that was using containers at that time. Of course, we were doing things like cartridges and stuff like that, which I'll spend a little bit of time talking about tomorrow. If any of you tune into the Gear D talk tomorrow. And Docker launched then in 2013. Docker is a company out of California, the Bay Area. The story goes that they were a platform as a service provider that really didn't see where they fitted fully in that market, but they knew they had this really cool technology called Docker, and they decided to open source it, and it's obviously taken off huge, so we'll get into that. But for the most part, then you'll see how in November 2013, Red Hat Enterprise Linux 6.5 launches with support for Linux containers. Of course, we don't always, we've seen some difficulties with the way people are using Linux containers today with things like LXC tools and stuff, and our approach is much more tied in with using systemd and stuff like that. So we've influenced a lot in the way in which containers are going to be consumed with things like Geard and OpenShift. So Docker 0.7 was released with support for in Fedora, and we're seeing recently we saw the RHEL 7 beta launch with new features for Linux containers, and pretty soon you're going to see RHEL 7 out there now. Everybody else okay there? I'm looking at the comments here. Everything seems to be okay so far. I'm doing self-moderation here. So what's all the hype? Well, Linux containers are a combination of kernel features like namespaces and control groups and SE Linux. Containers provide lightweight. Are people having trouble seeing the presentation, or are we good? Somebody says they've got nothing, but everybody else is good? Is it just one person or many people? Some people are saying it's good. We've got only 2, +1 for somebody else. It's good, it's good, it's good. Okay, no problem. So someone else is having issues. You might want to try Firefox. If you're using Chrome, things don't work. Firefox works. That's Glenn West is also pointing that out. Okay, so containers provide lightweight isolation of a process and the network and the file system spaces. But breaks up a single monolithic runtime concept and turns Linux back into this multi-instance, multi-version, multi-tenant OS. So every container thinks it's God, thinks it's root, and could do everything, but really it's isolated, and all of the namespaces within it are isolated. Docker builds on Linux containers, and it adds an API and also an image format. We talk about Docker in terms of containers. And when you look at the Docker commands, you'll see the Docker commands deal with they deal with 3 things, but they deal with, for the most part, 2 things, which are the containers and the images. And so images, obviously, we know those are the things that will allow us to run our container. And our container is the running instance of an image. So we'll see how we can, when it comes to containers, the point is that Docker provides a nice API for doing that. But the real power of Docker, for the most part, is this whole image and the image layering. And we'll get into that when we get onto the command line here in a moment. So it provides this aggregate packaging to bind application that's runtime dependencies for deployment into a Linux container. And the layering model makes it uniquely useful. So let's have a look at that layering model. We've got 27 people online now. Cool. Okay, so here's an example of a Linux kernel. The Linux kernel has basically things like LXC and DevMapper and SE Linux in it. This is your host. So this is, for example, your Fedora box or your Fedora VM or your RHEL VM, or it could be, I'm surprised my little graphic didn't show up there. That could be your Atomic, your RHEL Atomic based host there if you wish. So we'll talk about Project Atomic later this afternoon. That's something very exciting. So Atomic and Gearbd and Docker tend to go together. So on your host, then you turn around and you could install a Fedora image. And then you may decide that you want to install Java into that particular image. And then you might want to install Minecraft into that. So now you've got your Java for your Minecraft. As you install these different parts, every sort of everything you install into here generally goes into a layer for the most part. There's some subtleties around that we'll get into in a moment. But for the most part, think of these as there's a Fedora layer image, there's a Java layer on top of that, there's a Minecraft layer on top of that, and then when you run your image and it's a running container, then the top part of the container is your is the only part that's writable. So that way you can edit files, or you can update your Minecraft image and add plugins or whatever. Okay. So the idea then is you have a base image, which could be RHEL or CentOS or Ubuntu or etc. Then you layer in extra packages on top of that, which become separate layers. And when you run it, that's your container. And you could have lots of containers running on your host, as long as that host is has a supports LXC. So as long as it's kernel, whatever it is, 2.30 something or whatever, or above, for the most part, and ABI compatible, then any container will run in it. So for example, you could run your Ubuntu application on your Fedora box. Okay. Everybody good so far? Okay, so why does this become cool? Well, it becomes cool because then people like ISVs can do some fun stuff. Or so you get your RHEL, for example, your RHEL base, then you might add your platform layer. Maybe that's JBoss, or maybe it's some Fuse components, etc. Then your ISV turns around and adds their layer in, their particular application. Maybe it's a database, or sorry, maybe it's an application on top of a database, or an application on top of JBoss, etc. Then they may have a custom layer of content, etc., etc., etc. So all these layers come in, and eventually then you have your running container, which has all of these different products layered in on top of it, and components layered in on top. The one other thing we have to talk about here in terms of, so we have images, which we explained are layered. We have a container that's a running image, with the topmost layer is the writable layer on that. And the other part of this is, if you like, that third thing that we don't, is this idea of the registry. So first of all, let's talk about the difference between the registry and the repository and the index. So the repository is on a local host running Docker, right? And that contains your layered images. So when I do a Docker pull from somewhere, and I'm pulling down an image that's from a registry somewhere, I pull that onto a specific Docker host, and that image and any layers within that image go into my local repository. Then when I do a Docker run looks in my local repository for those images and brings up the container. If the image is not on the local repository, Docker will try to go out and find it in the default place, which is the Docker IO registry. And the registry then is where you either your host pulls an image from, or it's a place you can push changed images if you want. So with Docker IO, you'd have to register yourself and create your own repo up there. And then when you do a Docker push of your own images, they would go up to the Docker IO repo. You could do the same thing if you had a local repository or registry for yourself. So the Docker IO has a lot of, one of the benefits of it is it also has this concept of trusted builds. We'll see that in a moment. And there's also an idea of private images. So you could, for example, have Docker IO host your private registry if you want, so that other people wouldn't see it out there on the internet, if you like, but they're still hosted there. A bit like a public cloud or whatever, but this is for image storage. So you can also have other public registries, potentially. I can't think of one off the top of my head, or a private registry. And of course, Red Hat, we have a little private registry at the moment that we're playing with, and I'm actually downloading something from it right now. Someday there's talk of having federated, and there's still a lot of discussion upstream on what that looks like. So, for example, actually the best example is when I talk about an index. too. So when it comes to indexes, an index is a way of being able to search for a particular image. At the moment, this is a part that has not been open sourced by Docker. And they kind of want everything that's sort of searchable to go through docker.io. So you can build your own registries and all that, but you don't get the whole value of having an index, for example. And so in the same way, you know, I don't know where that's going to go, because one would think that someone could easily build your own searchable way of doing your index. But at the moment, that's just the way it stands. Another area is that whole idea of federation. You know, do you go through docker.io to find other registries, or do you go to your registry first and then default back to the federated Docker.io at some end of chain thing? Obviously, there's still a lot of discussion there, and obviously, we're going to have very strong opinions on it for what our customers would think of that. So stay tuned on that whole idea of federation, and stay tuned on that idea of indexes and searches. Okay, I was going to do this on the little drawing page, but I'm afraid to waste time trying to get that little camera thing working over here. So let's have a look at this. On the bottom right-hand corner, we have the container host, right? So that's your maybe a Project Atomic, either your Fedora Atomic or your RHEL Atomic host, and in it is running the Docker daemon. And with that, then I can do things like say, hey, I would like to Docker pull Fedora :20, for example. So Fedora with the version 20. There's some naming conventions there, but they're very arbitrary, quite frankly. So what happens then is the Docker pull will go out to the to docker.io. That's up there in the top left corner, and it pulls down the image if it exists, and it will pull down any layers that are part of that. So, for example, let's say the Fedora there's a sort of convention that if you don't specify a tag and you update a particular image, it'll end up with Fedora :latest or something like that, or RHEL 7 latest. So, but that latest may have some layers of yum updates that have occurred in it. So let's say then you download the Fedora HTTP image. It will have a HTTP image, and then it might have a latest image, and then it might have a Fedora 20 image, and et cetera, et cetera. There might be layers. So all of those go down into your local repository. And then when you run it and interact with the Docker daemon that way, so when you do a Docker run, your Docker run client talks to the daemon and says, here, launch that particular container. And you can obviously have multiple containers running at the same time. So we're going to look at this. Now I'm looking at the time. But before I say that, there's also, I might decide to download from the Docker Red Hat registry, which we are hosted internally. I'll show you a link to that in a while. And we can pull images from there. That might be coming in very handy for me right now, because I'm having great difficulties, whether it's the bandwidth here in Singapore or whether it's I think it's more likely an issue with DockerCon at the moment. I'm having trouble getting images pulled from Docker. So is that the last thing here? So what we'll do now is we're going to look at things like some of the commands like Docker pull and Docker build and Docker run and Docker link and all that good stuff. And we may look at Docker commit, where we can add our save a particular image. And then we can tag and rename images. And there's obviously a lot of other commands. And again, if you do a man Docker, you'll see the main Docker page and a list of all of the commands that are on it. And then you can do a man Docker inspect or a man Docker run or a man Docker pull and see the various commands there. But we can also inspect images and gives us metadata about it. We can attach to a running image that maybe we are detached from. We'll show that in a while. We can inspect, I already inspect an image. We can list the images that we can see. We can remove images. We can remove containers. We can save Save images, it's not like a commit. Save is where it wraps it up in a tar file. We can push up to a registry. We can start and stop, and there's many more commands. Why is it cool? Because it provides deployment flexibility. We could deploy our container up in the cloud if it supports Docker up there, presumably, and people are moving fast and furious to support Docker right now. Also, for example, with ISVs, and we'll talk about this maybe tomorrow more with GearD, but the idea that your OpenShift, the concept of cartridges, which seems, very Red Hat specific and all that sort of stuff. Now with containers, ISVs can build more standardized Docker-based approach to deploying some apps. So for things that OpenShift is taking advantage of that. Operational efficiency, simplified maintenance, lower, because now we don't have for example, in the cartridges world, where cartridges were a lot of scripting, etc., and maybe a little bit fragile in that way. Here you can just package it all up in a container, and once you launch the container, off it goes. All right, let's see. That's for tomorrow. Okay, let's go here. And that's the Minecraft one, so let's go somewhere else. Let's see if this got done. Okay, it did. This is really good. Yay! So what's cool about this is, can you all see this good? Is that good enough for you? Can I make the test a bit larger? Of course I can. How's that? Is that better? Let's see it come in. There, is that a little bit better? Better. Okay, if I go any bigger, if you can make your Firefox things a little bit bigger, it might help as well. That's much better, I think. Yeah. Okay, so let's have a look at this. This is actually a atomic box. This is a RHEL 7 atomic box. And I'll be talking a bit more about that later today when I talk about Project Atomic and how to get this thing up and going. Kind of doing this sort of backwards a little bit. So in this Project Atomic box, I just did a Docker pull, and the reason I'm not going to do it live is it's taken too long. The bandwidth here is hard. But look at this. It actually brought down, when I did this, I'm pulled from the internal repo. So I'm saying Docker pull, and then I give it the registry name. If I don't give it that registry name, then it's going to try to find this out in docker.io land. Then I give it a name. Now, let's just say this is a name for the moment, because essentially that's what this is. We will see here when I run Docker images that Docker likes to break this out a little bit and call the name the repository. And the idea there is that this higher level qualifier, this Red Hat part, and indeed, as you can see here, they like to say this whole part, but they like to add the repository as well. They call it the repository. Why? Because the idea is that you might have a Red Hat /RHEL 6, a Red Hat /RHEL 7, a Red Hat /RHEL 6.5, or what have you, right? So the idea is that this is kind of your registry for all of the other products you might put in underneath it. And it makes very good sense from a docker.io perspective. So if you're docker.io and you're an individual person like me who has a account there, for example, I don't know whether it's Whenry, I think it's Whenry, W-H-E-N-R-Y, which is my email address here. Then it's the Whenry/Fedora, Whenry/RHEL 7. So it's Whenry is the sort of repo, right? Our Red Hat is the repo, our Ubuntu is the repo, etc. But essentially that these two things here, the first part, the repository, and the second part are the name of it. And then the last thing after the semicolon is what they call the tag. It's again not a really smart name because, as you'll see, we'll use that differently. In fact, I've just pushed an update to the man pages to try to clarify this for people. But for the most part, we like to say that behind the colon is the version number, and it's the version number of the highest level, highest layer on the image. So for example, if you've got a Fedora 20 with a JBoss 6, you would turn around and probably have Fedora JBoss :6 because the JBoss is the highest level there. If you have the Fedora JBoss MyApp or whatever, you're the last, it might be MyApp 1.0 because you put the version of the topmost layer is the convention. But again, it's completely arbitrary. We could call it what we want. And in fact, let's do that. Docker tag. Now let me see if I can remember the Docker tag. So let's look at the man pages. Yay. Here's the man pages. And look, I can say Docker tag and I can give it an image and I can say here's the registry host and the username and all that good stuff. So let's do this. I can say Docker tag. And by the way, I can use the entire name here, but I'm going to cheat. I'm just going to say Docker tag this. And I want to just call it Red Hat RHEL 7 to be, or even RHEL 7 to be short. Okay, so now if I say my Docker images, all I've really done is rename it. But if you look at it, they both have the same image ID. Okay, so what have I done? I've pulled down this. We saw that from up here. I'm going to look at it as it is a number of layers. See these layers? Those are layers specified here. They're layers that have probably done yum updates and yum cleans and stuff like that in them. And then I just tagged it, and all it does is it renames it. So Docker tag is essentially should be probably called Docker alias and not Docker tag. And the reason is because they use tag for this column, the post colon column. Okay. So let's have a look at the image. Let's have a look at Docker inspect. I think I can do this. And by the way, it turns out that you can just provide a few letters here, and it'll just, did I spell that wrong? LF5, maybe I need another one. Oh, it's only on containers, sorry. I need to do a Docker, I was sure I could do a Docker inspect on that one too. Maybe it's info. Nope, there's a way of looking at that image as well, and I just don't have it off the top of my head right now. But the most important thing is we want to run it. So I'm going to say Docker run. Now, I've never done this with this image before, so hopefully it'll work. And I'm going to say Red Hat RHEL 7, I call it, because I can use the alias and I'm just going to do a bash. Please let this work. Come on. Yes. Oh, thank goodness. Okay, so that's the first time I've ever used this image, and I see that I have a bash here, which is nice. And I can, LS and all that good stuff in here. So what else do I want to do in here? I don't want to do anything in here, but let me do this just to confuse you guys. I'm going to do another tab, and I'm going to do, because that one's running over here, okay, here's my image is running, and over here I'm going to say Docker PS, and I'm going to see that in this world I am not connected to that because I'm in Vagrant. Okay, so I can't see if it'll let me do this here. Probably not, because I'm already SSH'd in. No, it will. Fantastic. It should do it. Great. So now if I do a Docker PS, I'll explain the whole Vagrant thing this afternoon. But somebody asked me for the kernel version there. So here, Docker PS, it shows me this container because of the horrible size of the screen. See, there's the image name. There's the command that's running. It was created about a minute ago. It's been up about a minute, and its name is Prickly Bratton for some reason, and it just comes up with these names. I could have called it something much cooler. And I can do a Docker inspect on this. So let's look at that. And in here, I see some groovy stuff. Let's see. I see the host name is that. I get to see that the image is called Red Hat RHEL 7. I see, what else do I see? I see an IP address and gateway, the bridge. We'll talk about that. There's a Docker, there's a bridge, network bridge, etc. So some nice information there about the container. Now let's see if I do it this way. So I'm going to exit out of this. Now again, this isn't something I've done before, so we'll see if this works, because I've had trouble with this on Fedora lately. Okay, what I'm doing now is I'm mounting devlog from the host with I'm bind mounting it to devlog in the container. So now when I run this container, oh, it worked. This is great because I was having trouble with this earlier. So if I just say logger Wenry's new container, okay, and if I exit out of here, I should be able to say in journal grep Wenry. Oh, no journal files were found. That's because I have to do I have to do this? I do. There it is. So what's really neat about that is I can now have lots of containers that are logging to their own devlog, and on the host I can see the output of all those containers in my local systemd journal, which is nice, right? Isn't that cool? It is cool. I think that's very cool. There was one other thing I wanted to show on that, and that is, okay, so let's have a look at this. What do I have here? Docker images. I have the Red Hat RHEL 7. So I'm going to try and do something here. I am going to try and create a...
William.
Well, it's going to be hard. It's going to be hard because it's RHEL. Let's see if let's have a quick look and see if it works, right? I'm going to create a Docker file because there's two ways I can do this. Let me just show you this first. Let's run this like that. I could turn around here. This will tell us if it works, by the way, and I could do a yum update, right? And that's exactly what I was afraid of. Okay, so the reason this isn't going to work is because this particular RHEL 7 image hasn't got the latest entitlement capabilities yet built into it. And this is important for you guys to know, is that we are we've worked on this. We've come up with a way of it, and we're working with upstream to figure out how do we get secret files, things like entitlements and other such things, maybe keys for encryption keys and stuff like that, into the build process for an image. There's two ways we can normally do an image. So now I'm going to change to this. Does everybody see this? Because of the bandwidth, I am not going to try and do some of these build stuff. But let's look at there's two ways of doing builds. One is to go into the bash image, and you could turn around and essentially do a yum install of a lot of different things, create files. You could do it all that way, right? So maybe you install JBoss, you SCP in some files into your image, you edit some other files, you change your index.html or whatever it is that you're doing in there, and you look at it and you're very happy with it, and then you exit and you can turn around and do a Docker commit that particular image name to a new image file, and you could call it the Whenry/JBoss super app, and now that's your new image with all those layers in it that are now part of that image. So those newer layers of all the things you install are on top, and then you can push it. A different way of doing it, and what you'll see out there a lot, is using a Docker file. And the Docker file, you basically use a base image. Now, for my demos that I was doing last week at some meetups, I was using a Fedora 20 base image. I obviously broke the convention there by putting 20 there at the end. But anyway, but I didn't want to turn around and have to install Java and do the pulls over Wi-Fi network in a library in Colorado or something, right? So at a meetup. So what I did was I built a base image called Fedora Java. And so what I'm saying here then is, so originally my Java one would have had a from Fedora, and then I did a yum install Java. In this one, now that I already have it built, I say from Fedora Java F20. Here's who I am. I'm the maintainer of this. I want to do a yum update and a yum clean all. Worth doing because a clean all gets rid of stuff out of your image. Then I run a make directory Minecraft. And then I add the Minecraft server jar. The Minecraft server jar from this directory, which is here. I added into the image in the /Minecraft directory that I just created in the here. I expose this port. I set up a work directory, etc. I can do some other things, like there's the entry point for this. The entry point is if I don't do the interactive mode like I was doing earlier with the Docker run -t minus u, -t minus I. So the -t was for the terminal, -I was for the interactive mode. And I was going in there with bash. But in this case, we'll see that I'm not going to run this that way. I'm going to turn around and just run it essentially this way and give it an entry point and say, hey, basically, when you run this, just when you bring up this container, run Java with these particular commands, right? Somebody's asking me, can I set the host name? I think you can, but I can't think of how to do that right now. You'd have to look at the man page for Docker run, or you might be able to do it within the Linux container in the network settings there. So there's a -lxc config option you can do on the run and do some network settings or whatever you want to do there. Basically direct Linux container commands. Okay, So when I do a Docker build of this, normally you will say Docker build. Let me just have a look at that. Watch. So, for example, before I was doing, here's another good example of a Docker build I did, where this is a cool example, actually. When I was doing my man pages, I was asked to do them in Markdown format and to convert them then into man page format. And I chose Pandoc because I couldn't get anybody to make up their minds on how they wanted me to do it. Everybody was saying it was a great idea, but no one had a consistent way to do it. So I just picked Pandoc. Maybe not the best choice. I don't think it was the best thing out there, but it was what I had at the time. And so the Pandoc would convert from Markdown into man page format. However, Pandoc isn't available on RHEL, so the guys like Lokesh and others were asking me, hey, how are we going to get this into the RHEL 7 build? And so what we do is, before we run the packaging for RHEL 7, we want to run Pandoc on all these Markdown pages, but Pandoc isn't available, as I said, in RHEL 7. Or if you're an Ubuntu person, maybe they don't have Pandoc there. So I created a Fedora Pandoc container, and if you go into the, I'm going to go over here. No, I'm not. I'm going to just go more. Tilde slash git slash docker slash contrib slash man slash md slash Docker file. Here's the Docker file for that. Basically, all it says is from Fedora 20, yum update install Pandoc, or yum update and install Pandoc. And then if we do a md2 man, we see this little script will turn around and run Pandoc on all the files, all the MD files in that directory, and convert them with the into man page format. Okay, see using the man. And how do we do that is down here you'll see that you can essentially build a Pandoc container and then turn around and run the container in this fashion and pass it and run the man script, man-do-d script. And so the container itself will actually generate all of the man page formats. Anyway, the other problem with doing a build today, as much as I would like to do it, is it takes forever. But let's have a quick look and see if we can do that somewhere here. So here's a simple one that will turn around and install HTTP, etc. from Fedora 20, if indeed I really even have it. Because I deleted Fedora 20 earlier because I wanted to do a yum pull of Fedora 20, or sorry, a Docker pull of Fedora 20, but Docker doesn't seem to have Fedora 20 anymore. So let's see if this works. Build. And the image name, we're going to call it Fedora/HTTPD for the Tech Exchange, and we'll give it the current directory in which to find the Docker file. And Docker build. What did I do wrong here? Did I give it the wrong password? I bet you did. Docker build, what am I doing wrong? Hold on. Yes, you do, Docker build. Minus T. I have to tell it the tag of it. What's the name of it? So it's now trying to find the image. So this is what I'm saying. There's some problem with the Docker today. So essentially, though, what's interesting about this to see is look at the different steps here. There's the image. Then when we turn around and do oh, that's why I have the wrong thing. That was me testing some problem there with the network before. So here we go, and out we are pulling down from Fedora 20. Here's another image. Here's another image layer. Here's another image layer. So be very careful with your Docker run statements. Every time you do something like that or do an add, you get another layer on your image, okay? All right, so while that's building, and obviously, look, there's mirror problems here with trying to find stuff on the network. So I'm going to kill that because the cool part here I wanted to show you before we finish. You see, what else did I want to show you first? Docker run, I showed you the Docker run. Oh yeah, here's what I want to show you. So here's my Minecraft. And I'm going to run this, and I'm going to run it. I'm going to basically, before I do that, more Docker file again. Let's have a look at that. Notice I exposed the Minecraft port for the server. So I want to map that port here. I'm going to do this. I'm going to give it a name just because I'm giving it a name, but that becomes handy when you want to link things. For example, if you've got two containers, you can say Docker run and link it to another container that you've named using minus name here. So for example, if you've got certain mounts or certain ports exposed that you want two containers to communicate over, you use the Docker run minus link to do that. Okay? The minus D here is to say I want to just do this in detached mode. And then I say Fedora Minecraft. So let's run this. And then I'm going to do a sudo docker attach, and I'm going to attach. By the way, this is the real long name of the container, but often it'll show up just as shortened, and often you don't even need all of that to do it. So I'm now going to attach to that container, and we may not see anything here because it's there's not much. Most of the work may have already been done, but let's see. I'll go over here and say Docker PS, and of course I have to do su Docker PS on this machine. I don't know if you can see that, but it's up and running here. So I could do let me make it bigger because I know you want that. So I'll say Docker su on this one, Docker inspect, and I'm going to inspect that particular image. And the reason I'm going to do that is because I kind of want to know what the IP address for it is, and we'll see it's there. Okay, so it's 04. Let's go back. Not seeing anything there. So 04. So let's go over to And I'm going to connect, and I'm going to put in a 4 here, and this hopefully will work. So now I've created a Docker container based on Fedora that's for Minecraft. And so any of you who have kids who like to host Minecraft and you want to do it in Fedora, you can do that now, although you might want to use the Craft bucket or whatever it's called version of it to do that. So this particular if I go over here again, I will see, look, that's my actual Minecraft.
William, you have 5 minutes.
And you can see that I logged in here, and if I, do anything, I guess I just earned an achievement, etc., for taking inventory and stuff like that, right? And if I
William, stop having fun. You have 5 minutes.
Chop down a tree or something, which I don't really even remember the commands for it. Okay, everybody hear me? Everything good so far? Got about 5 minutes left. I think I've shown you all of the different commands. Later on tomorrow or today, I'm going to show you the Project Atomic for those of you who join, and I'll explain why that's important to us, and particularly why it's important with the Docker containers. And tomorrow, I'll talk about GearD and why that's important to Docker. As you can see, Docker is very local host focused, and it deals with sort of single containers. And sure, you can link containers together, but you may want to do something more elaborate. Like, for example, if you're doing an OpenShift based application, how does it turn around and handle things like multi-containered apps? So with that, if any of you have any questions, please fire away. Was this useful so far? Did people get it? This was just sort of an introduction. Oh, useful links, by the way. Is this it? Somewhere here I have the Docker registry is internally is docker-registry.usersys.redhat.com on port 8080. Actually, I think if you just put in Docker registry usersys.redhat.com, it'll come up. And in here, I can do a show all, and you can see here's all of the different Docker images that are available for you guys to pull down and play with if you wish. I want to make sure that I'm correct in my timing here. Am I wrong? Is there more?
You're done. 2 minutes.
No, there's not more time. So if you have questions, does anybody have any questions for me? Here's the Docker IO registry, should be here somewhere. Oh, that's another point, actually. Here, I can do things like Docker search, and let's say I want a -trusted. I want to say I want a trusted build of what are the various Fedora images that are out there, and we can see a list of those, and apparently none, because I'm pretty sure that Fedora they must be down. Something wrong with the registry at DockerCon. I'm not seeing any questions come in. There's 31 of you out there. You want to put them on in the commentary box there before we finish? Up there, there's a blue. See this blue thing here? Let me see. Somebody asked, will there be tools? Sorry, I see there's some images. Well, Gear D is going to provide you tools for doing that. So Gear Build or Gear Install will help you. Gear Build will help you build particular images. So let's wait till we look at some gear stuff there. Let me see what else we have. Oh yeah, so you can Docker containers interact with systemd. When you see Gear D, you'll see that almost any of the containers that are deployed using Gear D will be deployed as services.
William, below.
I'm trying to look here. What else?
This is C, right?
This is C.
Everybody should be logged out.
They're not logged out. 28 of them are on.
All right. Is your session done?
Yes, I think so. Oh, by the way, before you go,
guys,
W. Henry at redhat.com with any questions. W. Henry, WHENRY at redhat.com, or on IRC. I'll be W. Henry there too. Thank you.
All right. Thank you, guys. This is an emergency. I'm going to kick you guys out to.
What's happening?